The name of the chapter is Current Electricity. We will have to study detailed about current electricity, but we should know why this chapter has been created, current electricity. In this scenario, you will know that when the charges are in two stages, the first one is at stationary and the second one is at motion. When the charge is in stationary position, then you will give its a term electrostatics, but when the charge is in motion, then it will be termed as current electricity. You should remember that electric charges are of two types. The first one is positive charge and another one is negative charge. These two types of charges were termed by Benjamin Franklin. Now we can define here the current electricity, that when the charges are in motion, then it is termed as current electricity or electrodynamics. Let's start with the topic electric current. It is also termed as current strength. So we can define it that current strength in a conductor is defined as the rate of flow of charge across any cross section of the conductor. Again, I am repeating that it is the rate of flow of electric charge. I think you should know the electric charges are of two types, the positive charge or negative charge. So you can take any of the charge to define the electric current. Flow of electric charge is measured in ampere, or in another word we can say that the SI unit of electric current is ampere. The electric current is represented by capital I, and we can establish a mathematical relation between electric current and electric charge, that I equals Q upon T, or we can say that Q equals NE. So we can establish a new relation, that I equals NE upon T. For non-uniform flow of electric charge, we can establish an integral relation between electric current and electric charge as I equals integral of dq upon dt. The electric current flows in a conductor because the conductor have some free electrons. If a substance have free electrons, then there will be a conduction of electric current through that. If electric current is flowing, it means free electrons are present. For the conduction of electric current through a conductor, it is very essential that we will require a alternate source of battery or an EMF. The given figure have two parts. In the first part, the free electrons is not connected with external source of battery. Hence, there is a random motion of the electrons in the given conductor. But if the source of battery is connected with the conductor, then the second figure follows, means all the free electrons are arranged and they are tends to move in a single direction. The next figure shows that if the number of free electrons are increased, then the magnitude of electric current is also increased, because the magnitude of electric currents directly depend on the electric charges. As you have already studied about Ohm's law for conductors in your previous classes, but once again we are going to define and once again we are going to study about Ohm's law. As we have studied earlier that at constant temperature, current flowing through a conductor of uniform area of cross section is proportional to the difference of potential across its terminals. That means if electric potential is increased, then electric current will also be increased in the similar way. It is the mathematical relation of Ohm's law which shows that the potential is directly proportional to the current, and a new term is generated which is resistance. So the resistance of a conductor is defined as the ratio between the potential differences between the two ends of a conductor to the current flowing through it. And the SI unit of resistance is ohm. The resistance is denoted by capital R or small r everywhere. The direction of electric current is opposite to the direction of flow of electron. If external potential is applied, then electrons, means free electrons, start moving, but in the opposite direction of that free electrons, the electric current's direction is taken off. Now, types of electric currents. According to its magnitude and direction of electric current is of two types. The first one is direct current and the second one is alternating current. Now, if you are going to talk about this direct current, its magnitude and direction do not change with time. Its magnitude and direction do not change with time. Just for an example, a ceiling, battery, or DC dynamo are the sources of direct current. In the similar way, alternating current is an electric current whose magnitude changes continuously and changes its direction periodically is called alternating current. AC dynamo is the source of alternating current. In this figure, clearly you are able to see that in the two graphs there are two different currents. The alternating current are shown by the option A and the direct current is shown by option B. Means periodically in the alternating current the magnitude and direction is changing, while in direct current the magnitude of current remains constant. Now we are going to discuss about the combination of resistances. There are two types of combinations of resistances, that is series and parallel combination. But apart from this, by the combination of these two in a single way, we can have a mixed combination also. In such type of combinations, a single circuit contains both types of combinations, means series and parallel. In series combinations, resistances are connected end to end, that is second end of first resistor is connected to the first end of the second resistor, and so on. You can see in the figure the types of combination which is in series. Same current flows through each resistance, but potential difference distributes in the ratio of their resistances, that is the potential difference is directly proportional to the resistance. So the total potential drop is equal to the sum of potential applied across the combination. Means the equivalent resistance is denoted by Req is equal to R1 plus R2 plus R3 plus R4 and so on. In parallel combination, the first end of all resistors are connected to one point and second ends of all resistors are connected to other point. Means same potential difference appears across each resistance, but current distributes in the ratio of their resistance, that is the current is inversely proportional to the resistance. Now by seeing a figure we will clarify that whether the figure contains series combination or parallel combination. In the first case you will observe that the resistor R1, R2, R3 and R4 are there. These R1, R2 and R3, R4 resistors are connected in series because the second end of first resistor is connected to the first end of second resistor, and the second resistor is connected to the third end of the resistor. Now in the second case, first end of all resistors are connected to one point and second ends of all resistors are connected to the other point. Hence we can say that the second figure is having parallel combinations. An electric cell is a source of energy that maintains a continuous flow of charge in a circuit. Electric cell changes the chemical energy into electrical energy. The next concept is electromotive force. Electric cell has to do some work in maintaining the current through a circuit. The work done by the cell in moving unit positive charge through the whole circuit is called the electromotive force of the cell. Simply we can say that when the cell is kept at the shop of the vendor, then it is known as electromotive force, and if the cell is switched in any electrical appliance, then it is known as electric potential. Thus we can compare the electromotive force and potential difference for an open and closed circuit as follow. Now it is time to define and to know about internal resistance. Internal resistance of a cell is defined as the resistance offered by the electrolyte of the cell to the flow of current through it. It is denoted by small r. Now we can say that resistances are of two types. The first one is internal resistance and the second one is external resistance. The external resistance was termed as resistors. The SI unit of these two resistances are same as ohm. Resistance is a measure of the opposition offered to the current flowing in an electric circuit. Internal resistance of a cell depends on the following factors. It is directly proportional to the separation between the two plates of the cell. It is inversely proportional to the plate's area dipped into the electrolyte. It also depends on the nature, concentration and temperature of the electrolyte and increases with increase in concentration. Similarly, we can talk about external resistance or resistor. On the same basis, the resistance depends on the following factors. It is directly proportional to the length of the conductor. Similarly, it is also directly proportional to the nature of the conductor, temperature, and is inversely proportional to the cross-sectional area of the conductor. The next topic is resistivity. The electrical resistance offered by a substance of unit length and unit cross-sectional area is called resistivity. Resistivity is the intrinsic property of the substance. It is independent of shape and size of the body and is depends upon the nature of the material. It is also known as specific resistance. Now we are going to start a new topic, which is electrical energy. It is defined as the total amount of work done by the source of EMF in maintaining the electric current in the given circuit for a specific time t. As it is very certain that in doing some work, energy is required. So, while bringing a unit positive charge from infinity to a point or from one point to another point, energy is required, and that energy will be consumed in the form of work done. So we can deduce a formula for the work done from potential. Since I means electric current is equal to charge upon time, hence that I can be put in the term of work done, means work done is equal to VIT, and then after we can have two more formula. Now based on this electrical energy, we can also define electric power or electrical power. It is defined as the rate of electrical energy supplied per unit time to maintain flow of electric current through a conductor. So we can say that power is the rate of using energy. We can have the formula of power as work done upon time, and this work done is stored in the form of energy transfer. So we can say that the power is also energy transfer per unit time. It is also equivalent to electrical energy per unit time. The SI unit of power is watt, the SI unit of work done is joule, and the SI unit of electrical energy is also joule. Time, which is very familiar, its SI unit is second. So you can say that power is equal to W by T or E by T. So you have the three formulas and you have the SI unit of each one on the figure. Now the next concept is heating effect of electric current. An electric current through a resistor increases its thermal energy. It means that if the current is passed through highly resistive circuit, then heating effect is generated. Also, these are other situations in which an electric current can produce or absorb thermal energy. Hence, totally this effect is known as heating effect of electric current. Mathematically, we can derive an expression for the energy which is dissipated from the heating effect of electric current by the using of Ohm's law as follow in the figure. Finally, you will have the formula of energy is equal to I square RT. It can be also termed in the term of VIT. The heating effect of electric current is also known as Joule's law of heating. Now we are going to deal with applications of heating effect of current, means the electrical appliances that we are using in our daily life that works on heating effect of electric current. In the same sequence, the first example comes for the electric bulb. In an electric bulb, the filament of bulb gives light because of heating effect of electricity. The filament of bulb is generally made of tungsten metal having melting point equal to 3380 degree Celsius. The next example is electric iron. The element of electric iron is made of alloys having high melting point. Electric heater and geyser work on the same mechanism because the resistivity or electrical resistance is much higher, and when current passes through this higher resistive circuit or current, then it is producing a heating effect, which in turn we are studying in electric iron. The next application is fuse wire. The fuse wire is made of tin lead alloy since it should have low melting point and high resistivity. It is used in series as a safety device in an electric circuit and is designed so as to melt and thereby open the circuit if the current exceeds a predetermined value due to some fault. In simple word, electric fuse is used to protect the electric appliances from high voltage